Okay, welcome to another tutorial session. In this tutorial, we're going to look at how to extract surface panels using points. The idea behind this tutorial is to be able to understand how surfaces are divided into point grids when you're trying to develop, let's say, panels on them or patterns on them, and how we can use these points for construction in a precise manner so that we can have a specific type of panelization on them. So let me first begin by showing kind of two different surfaces. So I'm going to first create kind of an open-ended surface. So this is like an arc section. And I'm going to do another one, which is going to be a cylinder. So one is open and the other one is closed. So if I, let's say, use both of these simultaneously, we need to explode the second one because it's like a compound volume. All right. So the tool that I'm going to do, I'm going to use is divide surface, which basically gives us a surface grid using UNB coordinates. We're going to talk about what these are, but essentially it's basically a point grid on a parametric surface, and this controls, let's say, the number of division or number of points. So it works for both open and closed surfaces. And if you have already looked into, let's say, the Lunchbox tools, the panels in Lunchbox tools, these are also calculated using surface points. So if I go to, for instance, these diamond panels and I plug in for the arc section, you can see it does a pretty good job of giving me these quads and triangles. It also does a good job for closed surface, but there's something else that I want to show you. So if you bake these diamonds here, you can see that the corner where we are supposed to see, let's say if it's a fully closed diamond pattern, the corner where we are supposed to see another diamond is actually has a gap, and that's because that's where the surface seam is. So if you also bake the triangles, you can see that this is the edge of the surface, and that edge we get for all lofts in 3D modeling. So essentially that's basically the start of the surface, and it kind of wraps itself around it, and it's a point of discontinuity, right? So Lunchbox is still treating the surface as if it's an open surface, basically. But I was thinking maybe in this tutorial we can discuss how some of these grids are constructed, and maybe you can use some of these techniques to develop other types of paneling systems for surfaces. So we're going to work on a closed surface, and we will try to populate these diamond panels in a continuous manner. And to do that, we need to start understanding how these surface points are extracted, how they can be filtered, and how they can be connected in lists. So I'm going to delete these and delete this one as well. So I'm going to keep this circular section. Let's actually, let me see, I'm going to move it around here. Let's move it back here. And I'm going to start with a 2D surface actually to discuss how the point grids can be constructed. So I'm going to create a surface and snap it to the grid. So let's put like a horizontal surface here. And I'm going to create a second script and load this up. So you can see that some of my points already coincide with the diamonds, right? Because that's how those diamonds are constructed. So right now we have 10 and 10 UNV divisions for diamond, but it's actually giving me 5 diamonds in each direction. So if I, for instance, highlight these points, you can see they kind of coincide. I can also make this 10, and we can see how the diamond pattern basically overlaps with the grid, right? So if I use these grid points, you can see I'm actually going from point to point, and this becomes kind of one of the cells within that grid that defines the quad geometry. So how can we develop these panels on the go without using this so that we can make it into a closed pattern? So we first need to understand how the surface is divided into points. So if you put in a point list here, and let's look at how the data is organized. So once I divide the surface into a point grid, I actually get these rows of points, right? So it goes from 0 to 10. We get 11 points in horizontal lists. And I'm going to make it asymmetrical so that the divisions do not correspond with each other, so that we can see how the lists are organized. So you can see I have 6 lists and each containing 11 points, right? And if we look at the point grid, you can see, let's actually turn this off a bit so that we can just focus on our own grid. So if these are my points, and if I want to draw a diamond pattern on it, I basically need to start from this point, go to this point, go here, and then close it, right? So this will have to be copied in a horizontal direction, and it also needs to be populated along these cells. So I'm just, because this is 2D, I can show you where those panels need to be. But what's important for us is how do we filter these points so that we can draw them? So how can we do that? So we basically need to be able to filter some of this data or information. So if I want to, let's say, grab these points, point 1, I can do it by using Cull Pattern. So if I use Cull Pattern, we know that the point lists are horizontal. So I'm going to use a pattern here and start with false so that I get rid of 0 and 2, but I keep odd indices, right? So if I do false and true and do multiline data and then plug this in, now you can see that I'm actually going to put spheres so that they're more visible. So you can see basically every time false hits, it hits an even index on the point grid, and then we're left with these points. So I can grab point 1, point at index 1 basically. Now, since we have already done this filtering, let's see if this coincides with our grid. So if I were to populate these cells here, I just need numbers 1, and then I'll make a secondary copy here, and then I need these indices as well. And then here I actually don't have anywhere to go. So if I want to place one more cell here, you see I'm exceeding my list. So this immediately tells me we probably need not 5, but 6 divisions vertically, right? So if I use 6 divisions and then I scale my pattern down, now you can see that we can actually fit 3 cells in the vertical direction to the point grid. But we only need actually, we get these columns, but we need 1 for each cell for the bottom points. So how can we find that point? So let's look at in each individual list now. So you can see we have we still have the data horizontal. So if I were to visualize these points, you can see we have horizontal lists being stacked up vertical. But if you want to do some filtering in the other direction, you can actually flip this list. So there's a tool called Flip Matrix. So if you flip this list, now our list will be reorganized. So it used to be 7 lists with 5 points going in the horizontal direction. Now when I flip it, it's actually now 5 lists going in the vertical direction, right? So the ordering also changed. So 0, 1, 2, 3, 4, 5, 6. That's basically now being traversed in the vertical direction. So what do we need? We actually need every even cell. So we can actually start doing that by doing another cull pattern. So let's do false and true again. Actually, we need true and false. So I'm going to do true, false. You can also you can use just this, but do a reverse here. So that will actually reverse the list that is being fed in, and it will just come in as true, false, basically. And this gives me basically 0, 2, and 4, and 6 as well. But since I want just these bottom points, I need to get rid of item 6. So let's look at those points. You can see now I have reduced it to this many points. And to get rid of number 6, all we have to do is shift list. And I can basically shift the ordering of a list in the positive or the negative direction. In this case, since we want to get rid of the last item, I'm just going to do -1 and make wrapping false. So I'm going to add a Boolean toggle here and make this false. And these are basically the points that I needed. So they are going to be the bottom point, the bottom corner of each diamond quad in this grid that you see here. So I'm just going to make a copy so you can see I have 15 points and I have 15 cells, and they correspond with the bottom corners of these points. So we basically got these. Now let's say we want to draw, how do we draw these cells essentially? So let's say we want to draw 2 lines, one from here to here, another one from here to here. And we want to just loft these 2 lines so that we can get those panels out, right? So just like the way we found these points, I need to find these points in this grid. I'm just going to circle them out. So I need to find this point now. So how do we find those points? So let's start again. So I'm going to go back to my surface grid. Initially we did false, true, but now we can actually do something else. We can actually do true, false. So I'm going to reverse this list. So we end up with these points. And I want to get rid of the first index. So let's look at what this list looks like first. So you can see we have 0, 1, 2, 3, 4, 5 going in a horizontal direction. Since I want to get start with the first index, I want to get rid of the first 0 points. So for that, we can actually do a shift list here. And this time I want to do in the plus direction. So I just plug in 1. Let me actually make this -1 to 1 and push this all the way up here. So now I have these lists. And then we need 1, 2, 3, 4, and 5. We need all of these actually. But just like the way we filtered them in the vertical direction, we need to do the same filtering here. So I'm just going to copy the flip matrix. Now let's look at our list in the vertical direction. And we need odd indices now, right? So I'm going to make a copy of the cull pattern. And we need basically false, true filtering. And this is actually what we need. and it already gives me the points that we wanted, right? So these are the secondary points for the diamond. So how do we connect them? Well, if you draw a line, let's see, we have 5 lists with 3 points each, and we have 5 lists with 3 points each. So if I draw lines, I basically get, so we cannot see them because of the diamonds, but if I delete the diamonds, you can see I basically matched this point grid with this point grid and got 1/2 of the diamond tile figured out. Right, so essentially now we need to match the same information for this corner right here. So let's do that. So I'm going to, we need to also organize this in a way because we're going to have a lot of them. So let's actually make this into clusters. So I'm going to just line these up in a nice way. And I'm going to keep it here. You can also group them. So if you, let's say, want to use this chunk a few more times, you can just right click and make it into a group, and you can move them all together, or you can also copy them basically. All right, so the next step is to be able to find these points, right? And we probably have them somewhere in these lists, but we already filtered them out. So I'm going to just turn off these spheres, and we're going to use the point display again, but I want to get these points now. So where are they? So let's see. This list gives me the odd numbers. This one gives me the even ones. So I'm just going to start by making a copy of this and look at the data. So remember we actually filtered the end of the list, the beginning of the list by shifting it in the positive direction. Now we can actually do it in the other direction and filter the end of the list. So if you look here now, I got rid of this end column. And after flipping, we basically want to use these points, right? Let's see, we have 5 and 3. So that's actually pretty good. So if I look at the points, these are the points that I wanted to use for the other half of the diamonds. And let's see if we can use a copy of this one as well, because I want to get these points now, the top points. So I'm going to push it all the way down. And let's see, this one actually gives me the points I want, but I want to shift it in the other direction. So I want to do this one is +1. Right, so this is basically a 5 and 3 list. So these are the other points, right? So it might be a bit confusing because the way I'm extracting these points is essentially we are extracting all the 4 points of a quad, right? And these cells that I had drawn initially. So these are the cells that we are trying to plot. And we got these 2 points, this 3rd point as well, and this 4th point are these essentially. So I'm going to keep this grid up here, and let's see what happens when we connect the line. So this is basically one corner of the quad. So let's see, we have how many lines here? We have 15 lines, and here we have 15 lines as well. So if I put these together into a list, let's make a weave list. And for this one, I think we need to first flatten this out and then graft it here. So we get paired couples. So now they're all coupled up. And if I loft, these are basically my panels. So this is like, I guess half of the work, right? Half of the diamond panels that we were able to plot. One thing though is we need to get these additional cells, but we're also going to run into a trouble, because you can see these cells are coinciding with the seam, right? So we need to do something special there to be able to connect the information. So if you got this far, now we're going to switch to a closed surface, because now we're going to work on the other cells and we want to make sure that the information is kind of closed. But essentially, we're just going to reuse some of this information that we already built for the other cells, okay? So I'm going to switch to the perspective view, and let's come down here and see how this looks on the cylinder, basically. So I'm going to right click, set one surface, plug this in here, and let's see. So I think we have, I think it's doing it horizontal, but we want it to do vertical. So I might just make a loft. Let's see, copy this in the vertical direction and then do a loft and see if this works. Okay, there we go. So what do we have? So I'm going to hide this, get our lofted surfaces and bake them. So this is basically half of the diamond panels, right? So they're kind of closing very well, but we need to build the other segment. So how do we do that? Let's work on that now. So I'm going to move back to 2D and then select one surface. You can also try doing this in 3D, but it makes it easier to visualize things or how things are connected in 2D. So this one is done. I'm going to just move these panels around. Now I'm going to work on these cells. So let's draw them. So I'm going to work on this cell right here, right? So we also have these triangle panels, which we can build or close at the end, but I'm going to first focus on how to build these. And the last one is actually going to, it looks like it's extending right now, but this point is going to be this point here, right? So that it kind of closes on the surface itself. So we're going to have, in this case, we're going to have two rows of these. So let's start by extracting these points, right? We probably have some of those points, I think. So for instance, these points we already had somewhere. So let's try to find where they are. So I had these points. Let's turn these off. Yeah. So this is essentially the bottom corner of these quads, right? And the number of it seems to be right. But we need to get rid of this guy here, the last one. So I can actually use this list as is probably. So let's see, let's look at the point list. So we have 0, 1, 2. So I need to get rid of the second index. So we can just make another shift list here, extend this further, move it aside and do -1. And this will be basically the bottom corner of these quads. Now the next point in line, I need to find this row here, right? So we need to find this row. So where are they? Let's find them. So this one is actually giving me these rows, which might actually work, but let's see. I think we also need to shift some of this information, but let's see if we have it somewhere else. This also has these points. This one is not what I need. So essentially, what we need to do is like get these points in and filter them out. So let's see. It could be actually this one. I believe. Yeah, I think this is correct. So if I use this list, but we need to also do another shift to this. So let's make another shift here, bring this list in. And this time I'm going to do a +1. And you can see I'm actually getting these points, but there's actually an issue here, which is basically, if I were to connect these two lists, let's look into them. This is like 10 points, this is 10 points, but my surface construction will go from this point to this point, right? But we want to go in the right direction. So for that reason, I need to do another flip matrix here, bring this list to horizontal direction, and then do a shift list. But this time I want to keep the wrapping on, and then I want to flip it back. So that does a few things. It basically keeps this information, but it changes the ordering of it. So let's actually see what we have made. So I'm going to move my point list here. So initially we had the list going in the vertical direction. So once I flipped it, it's going in the horizontal direction, 0, 1, 2, 3, 4, right? So this shift basically changes the ordering with wrapping enabled. So I will start from this point, which will make my diagonal connections, right? But this point at the end, it will actually connect to this fourth index, right? So that will create the wrapping effect that we wanted to achieve, essentially. And I just wrapped it back so that we get the same layer order with this one. So let's see what we get. If I do lines between these two, that is actually correct. So you can see that this diagonal line goes all the way from here to here, but you have to think about how this is going to work on a closed surface, right? So this point would actually coincide with where we want this this diamond to occur. So this edge is actually correct, and I'm going to move to finding these points now. So let's see. Okay. So I think we already have them. So let's see. This row. Actually, is it this row? Yeah, I think we can work with this row as well. And go to this list instead. But let's see how we can do that. So these can be the points that we use actually. So I'm seeing this list here, and we need to get rid of this last row. So I can just grab onto these points. So it's kind of nice actually. You get to use the same list information that you already filtered. So I'm going to do this -1, so we get rid of the top row and we find these points, right? So let's look at our point list and do a size there. Okay, so these are the points that I wanted. And the next points are going to be these on this row here. So where are they? They're probably here. Yes. So for this one though, we have to do a few more filtering. So let's see. Okay. This one, it needs to go here in this direction. So where are those points? I'm looking at here, but we need to get rid of this row. And I think that might work actually, because this point can connect to this one when it's like closed. So we can grab that one, make a copy here, bring this guy in, Okay, this one we're going to do plus in the plus direction. And let's see. So we probably need to do a similar filtering. So let's move this one here. So if I were to connect these two lists, let's make a line. You can see it's going in the opposite direction, right? That's not what we want. We want this to go in the right direction, not on the left direction. So again, we need to do something that we did here. So I'm going to first flip this list in the horizontal direction and then do a shift, essentially with wrapping. So I'm going to shift it in the positive direction by 1, and then it becomes something like this. So we will start with this point, and then I'll flip it back again. And let's see what we get. So we have 2 points here, and we have 2 points here. So let's connect this to that. Well, that seems a bit weird, but it's actually correct, right? Because you have to imagine how those points are going to connect once we do it on the wrapped surface. So this point needs to go to this corner here, but that point is actually here, so that we're actually connecting it to the other side of the surface somehow. So let's see if this works. So I'm going to switch to my cylinder here. So I'm going to plug this in to the cylinder and hide the cylinder. You can also hide the surface preview points. So let's see where these lines are. So you can see they look pretty good actually, because my seam was actually here, and you can see it's actually connecting to the end of the seam or surpassing it as well. So I'm going to do the same weaving and lofting here. So let's see what we get. So I'm going to flatten both lists. Okay, it's actually doing, I connected the points in the wrong order probably. Let's see. So one of them needs to flip. So we just need to change the A and B order for this. And there we go. So it's actually working quite well. So these are, this was essentially what we got on the seam, right? So there's a seam here. If I preview the surface again, you can see the seam here. But this way, we're actually building something over the seam, and it's not affecting our surface construction. So if I connect these two surfaces in and bake them, well, now we have basically the same diamond pattern all around. Okay, that's actually pretty good. So the next step is actually going to be to understand if we can control the numbering for this grid. So let's go back to our 2D, right? So you can also see the last panel here being drawn from this edge to this edge, but when it's closed, it's actually it actually looks like this diamond panel here. So what I want to know is if we can control the grid size now and our paneling actually works well. So I'm going to increase some of these numbers. So let's see if we do 20 here in this direction. I'm going to delete the grid I had, but horizontally it seems to work. But does it work when it's odd? It actually doesn't, right? It's because we get half a panel here, and we cannot actually deal with that. So this V parameter needs to be set to even numbers. So I right click here, go to edit, and then do this even. And now this would actually control my horizontal division. Let me turn off some of the previews. So I'm just going to select all of this, go to solution, preview selected off, and we'll see this clean. Okay, we see this clean now. And let's see what happens when I push this. So you can see it's also causing a similar issue for odd numbers because we get like a half grid here. So this probably needs to be also set to an even number. And when I do 8, it actually controls it pretty well. So this can also go up to 20. Right, so, sorry, this needs to be set again to even. Okay, this kind of works pretty well. Okay, so we built these. Let's see, we can actually add a few more things. We can try to patch these triangles. Actually, these are patched already. We need to get the top and the bottom triangles if you want to. And we can do it just like the way we did for how we filter the data. For these, though, we're just going to work with individual edges or points. So it's going to be just like looking at single indices in the lists that we filtered. So let's look at, let's try to do it in 3D. So I'm going to go back here, set my surface. So we have more panels now. You can see it works pretty well. So I want to get this top row here. So let's see how we can do that. So we can actually start extracting all of those individually, or you can use some of this filtered data that we have already built here. It's totally up to you. But I can also do, what I want to do is actually go and see if we can use these individual lists and just like try to patch this basically using 3 points, or we can find each of these indices as well. It's totally possible. Maybe we can actually look at another point list here. Let's see, this could be a very interesting opportunity to show something else. So I'm going to reduce this number a bit to 12. Okay. So what we need is to build panels that goes from these even indices of the first row, right? So we need to get the first list essentially. And one way to do that could be to, let's actually extract these points from here, pull them down and work here. Let's see. So I want to do, let's look at list item. And I want to look at the first index. So the list item gives me the seam. The first index is at the seam. So what do we need essentially? So let's say we do, okay, let's do flip matrix. And okay, when I do the flip matrix, it basically makes the rows go in the vertical direction, right? So my first index will be these points here at the bottom. And then if I do a flip matrix to those points only and look at that list, now we have 0 to 12 essentially, right? But we want to get all the even ones, sorry, all the odd ones. So I can actually do it by extracting these points. Let's actually try to do Cull Pattern here as well. And I'm just going to copy one of these true-false patterns. Okay, so these are the points that I wanted. Perfect. So there we go. So these are the 6 points that we can actually use these. So one way to use it, you can actually do a shift list to these points and keep the shift index to be 1, and if we do this true, what it will do is it will basically create, so this is my list, right? So it starts from 0, 1, 2, 3, 4, 5. If I do the shift list in the positive direction and keep wrapping on, what it does is basically it rotates the list, right? So if I draw a line between the initial list and the shifted list, I'll get these edges drafted. So we can take these edges and extrude them to these points to close up these triangular faces, essentially. So how do we get that list? Well, we can actually use them here too. So they are in the second row. So I can look at index 1 now, flip horizontal again, and try to filter it. And this needs to be reversed. So let's see, we have 7 points here. We have 6 line segments, right? So one of them has to be shifted. So I copy this, make this false. So I can do extrude to point. So these are my edges, these are my points, and there you go. If, let's say by accident, you shifted it in the wrong direction, like in this way, it basically creates a torque, right? So you need to do it this way. All right. So the same thing we can do for the top portion. So these are the bottom triangles. Okay, so how do we do the top portion? So we have, essentially we have the points here. So I can basically make a copy here. We flip the matrix, but here we can reverse the list, actually. And then supply this in. And that's actually a very quick way of doing it because I'm just doing the same operation that we did at the bottom to the top, right? So let's bring our surfaces in. So these are my triangles. And these are my diamonds. And we can just connect them to one surface. And let's see what happens when we increase the grid size. Well, it actually works pretty well. So one way you can use, let's say, if you want to control these surfaces somehow. So let me see if we can do area. It gives me the centroids. So what we can do, we can actually, I'll just do a quick randomizer. So I'm just going to scale them down, but you can also use any type of parameter to drive them. So I'm going to scale to a random list length. So I'm going to flatten this list. Okay, so that's going to be my scale. And I'm going to do a domain. Between 0.2, so 20% to 80%. Okay, so we want to scale. I can also make this into a flattened list. So how do we do the scale? So we can actually, yeah, we can extract the wireframe. Let's do extract wireframe. Join. All right, so let's see. Flatten. So I want to scale this down using the centroids, and this is my scale factor. So that basically gives me random pattern on the surface, but you can also drive it with attractors. And then if you want to connect them again, you can do a weave with the joint version and the scaled version, graft both of them, and then do a loft. There we go. So I'm going to hide the old version and hide the points construction. All right. There we go. So that's basically, they're all diamonds, right? And I actually didn't bake the triangles at the bottom. Let's bake them as well. So I can just connect them here. But these are lofted geometry, so it needs to be a geometry container. All right, so if I bake this, okay. Well, this one is actually flipped in the other direction, but I'll leave that up to you. So that's why, like, we're not getting the same color there, but this turned out pretty nice actually. So we connected. Let me turn off in my display options. So I'm going to do front face, then turn off surface edges. Okay, so we basically constructed a diamond grid on a closed surface, but looked at how to approach these sorts of pattern construction using surface points. And the tools that I used were Cull Pattern, these Boolean lists that helps me filter the data. And we used flip matrix, shift list, but always like checking how the data is being filtered, right? So we're looking at the point lists, their coordinates, their indices, and then trying to match the lists accordingly for the construction of the diamond grid, right? But essentially we can use this technique for the construction of a lot of different types of paneling techniques. I hope you can practice some of these tools, but essentially this will help you to be able to develop any type of patterning on a surface. So I hope this is helpful. I'll see you guys in another video. Take care.